This physics question made even the top students panic.
An athlete with mass 70 kg trains by performing press-ups with a load on his back. The diagram shows the perpendicular distances involved. The center of mass of the athlete is cm and the center of mass of the load that he is carrying is cl. The mass of the load is 6 kgs. What is the upward force exerted by his two arms? Now this is a question on moments. Over here, when he does push-ups, he comes down and back. Over here, it's toes that he keeps fixed. So the toes in this question are going to be the pivot. Now the center of mass of the athlete is this point over here. That means that PM is the center of mass, and center of mass is the point where all the weight or all the mass is considered to act. So you have the mass, you'll calculate the weight from the mass. So it's going to be 70 into 10, which is going to be 700 newtons, because weight is equals to mg, where m is mass and g is your gravitational field strength. Similarly, the center of mass of the load is this. So the weight of the load is going to be directly below or vertically below this, and it's going to be 6 into 10, which is going to be 16 newtons. Both these forces are going to produce a moment, and it's going to be anti-clockwise in direction. So moment or torque is equals to force into the perpendicular distance from the pivot. The force is going to be 700 newtons for this, and the perpendicular distance from pivot is going to be 0.9. So when you calculate this, you 630 Newton meter. Similarly, if you calculate the anti-clockwise moment produced by the load, it's going to be 60 multiplied by, now if you're thinking 0.3 is the distance, you are incorrect. The perpendicular distance that you're going to take is from the pivot. So the pivot is the toes. So the perpendicular distance from the pivot is going to be this, which is going to equal to 0.9 plus 0.3. And the answer for this is 72 Newton meter. So your total anti-clockwise moment is going to equal to 630 plus 72, which is equal to 702 Newton meter. Now the upward force exerted by his arms is going to be directly above the point, which is in contact with the ground. And this force is going to produce a clockwise movement in this direction, and the distance of this force from the pivot is going to be 0.9 plus 0.3 plus 0.1, which is going to equal to 1.3 meters. So the clockwise moment is going to equal to the force that you need to calculate, let's say x into 1.3. Now according to the principle of moments, total anti-clockwise moment is always equal to the total clockwise moment. So 702 is the total anti-clockwise moment. Equate it to this. From here you get x at, which is 540 newtons. So your answer is C.